All right, welcome to Module 3. This is a review on trigonometry. Now, I understand that a lot of you are coming from a lot of different places in math class. I believe the requirement for AP Physics is geometry. A lot of times the recommended level is concurrent enrollment and pre-calc, but honestly, the math behind that it doesn't support it. So in this class, this is an algebra-based physics class. Most of what you need to know for math-wise, you learned in 8th grade. It's really not difficult in terms of the math. Now, the physics part that's obviously the tough part, but there is one key thing in trigonometry that we're going to use quite consistently throughout the course of the year. I can guarantee you, if you took a trig class, you are extremely comfortable with this already. It's probably the simplest thing that you do in a trig class, and that is, of course, SOHCAHTOA. Now, SOHCAHTOA is simply just a way to solve for unknown things only in a right triangle. Now, here's the thing, though. In AP Physics, could we possibly work on non-right triangles? Sure. But we will never do that. We will always break things into right triangles to make it easy for us to understand. And all this means is that if I have my reference triangle here, and we're going to say where the x is, that's my theta. Depending on what I'm looking for and what I have, I can solve as long as I have two things. Okay, so the trick for that is, okay, so this S for SOHCAHTOA, that's sine of theta. The C for ka is cosine theta, and the T is tangent of theta. So in all three of these cases, one of my unknowns is theta. Knowns or unknowns. And if I have, in sine's example, if I have opposite and hypotenuse, I can solve for one of these three. Okay, so these are like grouped together. I'm probably not explaining this the best. I'm not a math teacher, but essentially, if I have two out of these three, I can solve for the third. Now, one thing we have to be careful of before I get into more of this is your calculator. Should your calculator be in radians? Should it be in degrees? Right? What mode should your calculator be in? And I have great news for you. 100% of the time that you are in AP Physics 1, literally 100% of the time, we're going to use degrees. We will never not use degrees. And the only time it matters is for stuff like this, okay? So that's on you, unfortunately. If you're in, depending on what math class you're in, you might be using the radians all the time. And 100% of the time in that class, you might be in radians. Well, 100% of the time you're in AP Physics, you're in degrees. So it's up to you to make sure your calculator is in the right mode. And quite often I get kids saying, my stuff's not working out, like my math's not working out. And I'll be like, well, what mode's your calculator? And they're, radians. I guarantee you that if you forget to change the mode of your calculator and you don't check that first before asking me a question about why your calculator's not working, I'm probably gonna make fun of you a little bit. Not gonna lie, that's one of the things that I do. I'm gonna make fun of you. So anyway, sine, opposite hypotenuse, cosine, adjacent hypotenuse, and of course tangent is opposite and adjacent. And essentially, again, if I have two of these things, I can solve for the third. These are just all grouped together. Now, some of you might say, well, what if I have opposite and adjacent and I'm looking for hypotenuse? Well, you can do that too. That's called a squared plus b squared equals c squared. So anytime we have a right triangle, as long as I have two things, it doesn't matter what two things, I can solve for the third thing, okay? So if I have, for example, if I'm looking for theta and I have hypotenuse and opposite, and I'm looking for theta, I go to, well, opposite is O, hypotenuse is H. I'm going to go ahead and use the sine formula. And then I know that the sine of theta and the next two things are what the fraction is, opposite over hypotenuse. Now, if I'm looking for theta, theta is going to be the sine inverse of opposite over hypotenuse. And that's it. That is all we're doing. That is the only trig that we do in this class. So let's just do a couple examples. Okay, so my first example is find A if given C and theta. So here's my triangle. I'm looking for A. I have C and theta. Now in this case, this picture is a little different. Theta always references the angle that you know. And A and B, whether they're opposite or adjacent, that can switch. If my theta is up here, B is now opposite. If my theta is where my theta is, A is now opposite. So you just got to be careful about that. But I am looking for finding A if given C and theta. So A is opposite, C is hypotenuse, and I'm theta. So that's opposite and hypotenuse, so that's going to be sine. So the sine of theta equals opposite A over hypotenuse C. And now if I want to get A by itself, I'm just going to multiply by C. So A equals C sine theta. And that's it. All right, we're just making up a quick little equation. All right, next one. Find B if given A and theta. Well, here's B. That's what I'm looking for. Here's A, here's theta. Now I have opposite and adjacent. So I'm going to use tangent. Tangent of theta equals opposite, which is A, over adjacent, which is B. If I'm looking for B, I got to multiply it across and divide by tan of theta. So B equals A divided by tan theta. And that's it. It's as simple as that. SOHCAHTOA. Huge, okay? And then finally, our last little example here, find theta if given B and C. So here's theta. Theta is what I'm looking for if given B and C. Well, B is adjacent, C is hypotenuse, so I'm going to use cosine of theta equals adjacent B over hypotenuse C. And I'm looking for theta, so the way I get it by itself is by taking the inverse cosine. So theta is going to equal the inverse cosine of B over C. And that's it. That's all there is to it. Like I said, the only other thing, if I wanted to add a fourth example and say, find C if given A and B, well then C is going to equal the square root of A squared plus B squared. And any, I don't know, fourth grader can tell you that. When do you learn Pythagorean theorem? I have no idea. I want to say fourth grade. Or am I way off on that? I don't know, whatever. Fill it, write it in the comments below when you learn Pythagorean theorem. So that's it. That's all of the trig that we're going to do. So you might ask yourself, well, why do we have to do this? The only reason that we're going to use this in physics is what I like to call breaking things into components. And this might not make sense right now, and that's okay. But if I fire like a projectile, which is like any object that falls through the or flies through the air in which the only force is acting on is gravity. So think about like throwing a football. It's got some velocity, v. Well, within that, it has a x component of the velocity, and it has a y component because it's also being thrown up. Now, this y component is the same on both sides, and if that is launched at some angle theta, if I know the velocity, let's say the velocity is 30 meters per second, and the angle is 30 degrees, I can get Vx and Vy because I have the hypotenuse, I have theta, and I'm solving for Vx and Vy. So we're going to do that a bunch. We're not going to do anything more with that right now. I won't even finish that thought. But that's all we're going to use this for in physics. That's literally it. It's breaking velocities and breaking forces into components, the x component and the y component. So with that, if you have any questions, let me know. Otherwise, you should be all good to take the trigonometry review quiz. Best of luck. We'll see you in the next module.